All right, think about this for a second. What if you could build a working machine that's smaller than a single one of your red blood cells? It sounds like something straight out of science fiction, right? Well, it's not. It's the very real world of nanotechnology, the science of engineering things on an atomic scale. And today, we're going to dive into how this incredible field is already changing our world, literally, one atom at a time.
Okay, so before we get into the wild stuff, we've got to wrap our heads around the scale we're dealing with. Just how small is nano, anyway? Because, it's a word we hear a lot, but it refers to a world so tiny it almost breaks our brains.
All right, let me try to paint a picture for you. Imagine a beach, a really, really long beach, stretching for 1,000 kilometers. Now, pick up a single grain of sand. The size of that one grain of sand compared to the entire beach, that's the same relationship a single nanometer has to a full meter. We're talking about an unbelievably tiny stage where all this science is happening. So this whole field didn't just pop into existence, It started out as a really bold idea, a vision, really. It was so far ahead of its time that we actually had to invent brand new tools just to see if it was even possible. Let's take a look at the dreamers and the big breakthroughs that brought it all to life. Our journey really starts with this absolute legend, the physicist Richard Feynman. Back in 1959, he gave this incredible speech where he asked a question that was both simple and totally profound. He said, "Why can't we write the entire Encyclopedia Britannica on the head of a pen?" I mean, think about that. This was pretty much the first time anyone had seriously talked about manipulating individual atoms. He basically laid out the blueprint for the entire field. So Feynman's speech in '59 was the spark that lit the fire. Fast forward about 15 years, and a professor named Norio Taniguchi finally gives the field its official name, nanotechnology. But the real game changer, that came in 1981 with something called the scanning tunneling microscope, or STM. And then, just a few years later, in '85, scientists discovered fullerenes. You might know them as buckyballs, which proved that, holy cow, we can actually create brand new, super useful materials at this crazy small scale.
Just look at this. What you're seeing isn't a computer-generated image. Nope, those are real individual atoms. This is thanks to that STM I just mentioned. It was invented by Gerd Binnig and Heinrich Rohrer. They even won a Nobel Prize for it. And it was the breakthrough that finally let us see the atomic world. It's wild how it works. It basically feels the surface with this incredibly fine tip, and it uses a weird quantum effect called tunneling to build an image. For the first time ever, we humans couldn't just see atoms, we could actually start to interact with them.
Okay, so seeing and poking atoms is one thing, but how do you actually build with them? Well, it turns out there are two main schools of thought on this, two totally different ways to go about creating things on the nanoscale. On the one hand, you've got the top-down approach. The best way to think about this is like a sculptor. You start with a big block of marble, and you just chip away everything that doesn't look like the statue you want. On the other hand, you have the bottom-up approach. This is more like a bricklayer, right? You start with individual bricks, or in this case, atoms and molecules, and you carefully assemble them one by one to build your final structure. And you know what's funny? The top-down method is something we're all super familiar with, even if we don't realize it. Every single computer chip in your phone or laptop was made this way. Engineers take a big wafer of silicon and just etch these unbelievably complex circuits onto it. They're basically carving on a microscopic scale, making things smaller and smaller with every new generation. But the bottom-up approach, now that's the really radical vision. This idea was championed by an engineer named K. Eric Drexler. He imagined these tiny little molecular machines, which he called assemblers, that you could basically program to build anything you want, atom by atom. And when you think about it, that's exactly how nature does it, right? It builds everything from a single strand of DNA to a massive redwood tree, all from the bottom up. Now, I know a lot of this might sound like it's decades away, something for the distant future. But the thing is, nanotechnology is already here. It's quietly moving out of the labs and into the real world, into products and tech that are already starting to shape our lives. And the applications are just mind-blowingly diverse. Take medicine, for example. We're not just talking about making smaller pills here. We're talking about designing nanoparticles that can literally hunt down cancer cells and destroy them, all while leaving healthy cells completely alone. Or in energy. It's not just about making slightly better solar panels. It's about using materials at the nanoscale to capture sunlight with an efficiency we've never seen before. That could totally change the game. So let's break that down, that cancer-fighting nanodrug. How does it actually work? Well, think of it like a microscopic smart bomb. Step 1, you encapsulate the powerful medicine inside a tiny nanostructure, like a little capsule.
Step 2. You design the outside of that capsule with specific markers so it will only lock onto cancer cells. And step 3, once it reaches its target, and only then, it releases the drug. It delivers the payload exactly where it needs to go, which means way fewer side effects because the healthy tissue is left alone.
And believe me, this isn't some niche hobby for a few scientists in a basement. There is serious money pouring into this field from all over the world. Just as one example, the International Iberian Nanotechnology Laboratory over in Portugal gets about 30 million euros every single year. When you see that level of investment, you know that governments and huge industries are betting big. They believe this is the future.
But with any technology that's this powerful, you know there's got to be a flip side, right? For all the incredible promise of nanotechnology, there's some pretty big risks we need to talk about. And frankly, the debate about where this is all heading is just as important as the science itself.
So what are we talking about here? What are the actual risks? I mean, when we get the power to literally engineer matter from the atoms up, we have to be really careful and think about what could go wrong.
Okay, one of the biggest and most immediate concerns is something called nanopollution. We're creating these brand new man-made particles that have never existed in nature before. And they're so small, they can get basically anywhere, into our cells, into the food chain, into the environment. And the scary part is, because they're so new, we just don't know what the long-term effects on our health or the planet are going to be.
And then, of course, there's the one you've probably heard of, the big sci-fi nightmare scenario, gray goo. The guy who championed the bottom-up approach, Eric Drexler, was also the one who warned about this. It's this hypothetical doomsday where self-replicating nanobots get out of control and just start consuming everything on Earth to make more copies of themselves. Now, to be clear, most scientists think this is extremely unlikely, but it's still a really powerful reminder that we need to be thinking ahead and have some serious controls in place.
So, that leaves us with the big question, doesn't it? Is nanotechnology the ultimate key to unlocking a healthier, wealthier, better future? Or is it a Pandora's box that we're about to open, full of risks we can't even imagine yet? The honest answer is, it's probably a bit of both. What kind of future we get from these incredibly powerful new tools? Well, that's going to depend entirely on the wisdom of the choices we're making right now.